Okay, hopefully then this is where we get part 2 done. So, because we've got a whole load of iteration loops and stuff like that, I'm going to do part 2 in a couple of different functions. So we're going to do a single iteration in one function, which is going to take data, which is a reference to a string, and we're going to take phase settings, which is going to be an owned vec of string. Yeah. String. There we go. It's going to return a string. So we'll deal with parsing strings as numbers in the owning one. So the first thing we need to do is set up tx0 and rx0. Now, these are going to be a bit funky. tx0 is the output of the last amplifier. Rx0 is the input of the first amplifier. So I've got my proof of concept of how this is going to look. Okay, and it's these ones here. Noting that Rx0 needs to be mutable. Cool. So Rx0 is the receiver, which is going to be part of the input function for the first amplifier. Let's get rid of that squiggle. And this needs to know that it's going to be of a string type. So the very first thing I want to do is, according to the spec, the first thing we give it is the phase, and then we're going to give it some data. So the first thing I'm going to do is I'm going to transmit on tx0 the phase. So let's do this in let phase be equal to phase settings pop unwrap. Right? Let's get that out there. So we're going to send phase and channel closed unexpectedly, sending phase information. Okay. Then we also need to send our initial data, which is a 0. Closed unexpectedly, sending an. Oh, come on, you were just there. Sending initial input. Cool. So those are our initial channels set up. And phase settings, it's mute. Other way. Mute phase settings, there we go. So, tx0 is going to eventually be assigned to our last computer, but the first thing we need to do is send the phase information to computer 1, and then send the initial data. All the other channels, the first thing we're going to send is the phase information, and then we will worry about the initial data later. I have actually been playing around with how this is going to look. Let's call it amps. Here's that. Let's space these out. For nothing in 1 to 5 inclusive. So there's a lot of looping going on, a lot of weird stuff happening. Here they're called A, B, C, D, and E. I'm going to call them 1, 2, 3, 4, 5. That's the natural way of speaking about them. So I'm going to iterate over 1 to 5 inclusive, just for headspace. So the first thing we want to do is create a new set of channels. Then we want to create our input function, which is going to be a move closure, which is going to take our receiving channel, Rx0, it's going to receive on it and it's going to unwrap it. It's going to expect it. Receiving channel, channel closed, receiving input. Yeah, cool. And we're going to return that. So now we've got an input function which is going to take ownership of Rx0, and it's going to hold on to it and it's going to keep receiving data out of it. The first piece of data this particular input function is going to get is a phase number and 0. Then we are going to create our new computer with a copy of our input data. TX1 is going to be the channel it sends out on, and it's going to take input function. Okay, now this is going to complain, and it's going to say Rx0 has been moved, but we're inside a loop. So what we need to do at the end of this is we now need to see Rx0, which we made mutable, is equal to Rx1. So we're going to now transfer the where Rx0's variable is pointing into a new channel, or to point at a new channel. And then at the very end, once our loop is finished, we need to take our last one, and we need to set the output store. So it previously would have, what's its output store going to have been? TX1. So is there going to be a pair of channels we don't care about? Yes, we need to replace. So the last iteration of this, because we've already created a pair of channels here, the last iteration of this is going to create a pair of channels we don't care about, and then it's going to get thrown away. So this needs to be TX0. And then we are going to, what don't you like about that? Because last is not mutable. And then we're going to pop that back in, or push that back in even. Okay. So now we've got a series of computers wired up to output one to the other. When they call their input function, which is when they receive an opcode for 3, they're going to try and get a value off of this input channel, and they're going to block. So we need to make sure these are all on separate threads. So now, for a thread in, again, 1 to 5, let's make some handles. Because otherwise the program will finish before we wait for these to finish, which would be not ideal. Let's keep this in a few lines. It's going to be thread spawn. It's going to be a move closure. We're going to move the computer into it. And the function it's going to take, so actually we're going to say let comp be comps.pop the amp. And we're going to take ownership of that, and then we'll use it in here because we're going to do amp.runProgram. And then we'll say handles.pushHandle. Okay. We haven't yet got thread imported. Use parentheses to call this. So there are two traits in Rust called send and sync. And they denote what things are safe to send across thread boundaries and what things are safe to share across thread boundaries. Now we haven't specified that our function needs to be send. Now it is unique, so we might be able to get away with just making it send. If we can't, then this is not the last. It's a box of a thing that is also send. And you are unhappy now because my function is not send. Ref cells send. So a box itself cannot implement send. The thing inside it has to be send. This is possibly going to be a case of, tell you what, stream break, and do some research, and I'll be right back. Okay, that was easy. So actually all I needed to do was just, so I'd said that my int comp needs to take an input which is a boxed in fun mute string, which also is send. But in my constructor, I had not added the send to that. So now, all good. Now it's complaining that amp is not mutable, because it's not. So I think this possibly should work. Now the only thing is that I actually want a copy of the output data from the final amplifier, and that's this one. So the final amplifier has this output store tx0. So I actually want to do this tx0.clone, and then my final value, which is going to be a string, oh, this is interesting. So I'm kind of relying on the idea that due to the way the input is set up, amplifier 1 is going to terminate before amplifier 5. So amplifier 5 will push its second to last value down tx0. Amplifier 1 will take it and will terminate, and will never try to call a value off of that channel again. And then amplifier 5 will push a final value down, which we can return with tx0, not tx0, rx. Oh, have I cloned the wrong thing? Yeah, I've cloned the wrong thing. I need output to be rx0.clone. Okay, not clone. String format receiver. Copy. It's got to be. It's going to use a copy or clone. What don't you like about clone? Surely not. No. Okay. Channels. Create receiver. Receiver. Receive. That means I need to go change a bunch of types when there's probably a nasty, easy way to do this. So normally I'm going to need to drop amp after this point. No, I don't. No, let's assume all the computers are going to end naturally. That's fine. Dropping is not a problem. So what I want to do is for h in handles, h.join.unwrap, and then I have popped the amplifiers in here. I guess I could use a thread-specific channel to pump data out. What can a thread return a value? I think a thread can return a value via join. Spawning thread. Returns a result. Yes, okay. So can I return from my thread? So let's make UI. Can I return from my thread a tuple of I and no, this isn't going to work. I know what I want. If I is 5, this is very, very hacky. If I is 5, if I is 1, what I want to return is amp output store can't send receive expect channel closed on final output. Else let's return an option. This is a perfect use of option. Some, that, else none. Okay, so oh shit, yeah, it's on the input. So what I would need to do would be either I make the input public, which I had thought I was going to need to do anyway, because I thought I might need to change it. So I'm going to have to do input and yeah, can't unwrap because it's just a type string, I think. So let R be equal to handles if into iter join. So it's going to start with the first one, and it's going to join the first one, and that's actually okay. That's going to block, and it's going to wait basically for the output, and then the others will already be finished. Hopefully. Dot join collect string join is going to return So hang on, we're going to get an iterator over result t. Right? So join is going to return a result of type t, where t is just whatever thing is. So into iter map, there we go, h.join .unwrap .expect failed to join thread dot collect dot, we can filter this to have some value x, and we're going to do x dot is sum. It's going to be a vec of string. There's a map filter, but I mean, that's what I wanted. Filter map. The return iterator yields only the values for which the supplied closure returns some value. Oh, so I think I can just do filter map x. I suspect there is probably a method that actually is more useful for this. Collect. And we're going to do our pop unwrap is the value we return. Looks like I've got a brackets problem there. That needs to be a function call. So far, this looks all right. Apart from, I don't need to use that anyway, do I? So that's fine. Okay. What don't you like? Where are you? Where's my red and squiggly? There it is. Okay, you're a vector string. And you need to be mutable. Whew. Okay, so hopefully that works. If it doesn't, then fuck it. So now what I need is once again, I need my max output, I need my combo, and I need my, what was I doing with mute output here? Do that. So max output is going to be the minimum value of knife size. So we're going to have a combination. I'm going to set an output to be 0, and then combo is a vec of strings, which is our phase settings. So we're going to say that output be equal to single iteration on data and combo, and then if output par's I size greater than max output, then we'll do that, and we'll return max output. Brackets issue? Yes. That. Cargo test A7. Right, so infinite loop, excellent. Time to do some debug printing. First off, Oh, debug printing doesn't work in tests. So I guess what I'm going to want to do is see if we get to this line. No, we don't. Okay, so basically the thread is not finishing, which presumably means that there is a chance we don't reach terminate, which is actually okay, because I guess what we could do, we don't need to join on all of the handles, we only need the last one. But the problem is that the output, if the output for handle 1 doesn't finish, then we have a bit of a problem. I can't clone the input function. So just to show that we could make this finish, but with dummy data, let last be handles dot pop unwrap last dot join dot expect thread panicked return 0 string. Right, this should finish. Right, okay, that is exactly the issue. So basically, it's not guaranteed these programs are going to reach a terminate state. The only thing we can guarantee is that the last program will reach a terminate state. And the last program is going to push its output into a channel that we can't really access. Because you can't clone channels. But you can, yeah, cloning senders wouldn't help. Tricky. I think the really hacky way of doing this is you say you have a pub last output option string. When you create a new one, you say last output is none. And then when you run an output, this one, you do let out val. It's going to be self load mem. It's going to be everything up to there. And we are going to do self.last output is some out val clone. Store last output is going to be none. And that means that we're going to happen, though this I don't care about anymore. And what I care about this is actually this. If it's 5, give me the value of your last output. Which is already an option, so we don't need to double up on an option. That's fine, those have the same type. So we're going to return, just going to unwrap it. No, still unhappy. So why was that finishing before? Because this is blocking. So what did we just do? Because that was going to be fine. No, it wasn't. Oh, that was me. So was it really just this? No, it wasn't that. What did I change? Let's walk this back. That was the version that was definitely not good. Yeah, okay. So this that did finish, but doesn't anymore. Okay. Okie dokie. And the reason is presumably that the can't be because of this change. That would be dumb. Types are all correct. Compiler would have complained. Am I running or testing? Testing. Okay. Yes, I think this is going to require some offline debugging. Okay, nothing like print line debugging. So I asked my input function to tell me, what are you receiving? What amplifier number are you? What did you get? And here's where we stop, basically immediately. So amp number 1 receives 9, which is its parameter setting, and then the input of 0. Amp number 2 receives 0, and then we pause. Now it shouldn't be receiving 0, it should be receiving its phase setting number, which I'm not giving it. So hopefully the issue is simply that this needs to move. This all needs to move. So this is happening exactly 5 times. I'm creating a new amplifier. So I need to be careful here, because TX1 needs to get phase data. So if let sum phase is equal to phase settings.pop, TX1 send phase. That, hopefully, is going to absolutely flood my screen. Yeah, that looks okay. Let's get rid of that print line for a second, just run the test. They both passed. Let's go get that value back. It's always something silly. Nice. Now I just stitch all these together. But that wasn't a concurrency problem, that was simply I didn't do the job properly. So let's tie this up. That can now be an underscore. So the big issue here is the fact we need to link a whole bunch of stuff together. That's a real pain, right? Or rather, it's the fact that the last one needs to loop back round to the first one, which means we need to do all this funky stuff about creating the first one outside here, and then stacking it back on, and we're actually throwing away our last pair here. Nonetheless, that is concurrency in Rust. We've got memory safety. Remember, we are strictly requiring that we have this trait called send, which means this thing is safe to send across thread boundaries. Now, if this were taking a mutable reference to something that's in the main thread, if I took away, where do I create the input function? Where do I create the input function? Here we go. If I took away this move, right, rx0 would be a reference to something in the main thread. This is no longer send. Although it wouldn't be a mutable reference, this is a bad example. If I went back to what it had been doing in part 1, here, right, if this weren't move and this did not implement copy, then what it's going to do is it's going to have a reference to some data that's sat wherever inputs has gone. That can't be sent because we can't guarantee the two threads are not going to try and mutate that data, try and access it, whatever. So you'd need to wrap it up in something that is send, like an atomic reference mutex. Those are two separate things, by the way. I don't think the mutex on its own is send. It needs to be wrapped up in a reference counter type. Trait implementations. Oh, it is send. So the mutex is send. But T must be send. T might not need to be sync. Okay. So if you can't send it across, you just can't send it across. So what about an atomic reference count? Arc is not send. No, come on, it's got to be. There it is. So arc is send for any type T where T is also send. So everything has to be send, basically. Well, never mind them. But basically, Rust will not let you send data across threads that it thinks you cannot safely send across threads, and it will enforce that at compile time. I had assumed a mutex would make stuff send, but clearly not. And then sync means it must be safe to share across threads. And we're not sharing across threads at the moment, so it's not a problem. That's why we only need to enforce it as being send. And it just works, or being a bit messy. Now, obviously, there are a whole load of helper libraries around to do this, especially for, we haven't got to async yet. If we get to async, you get to things like Tokyo, which is a runtime, which provides a whole load of helpers. But fundamentally, for starting up different threads and having them all communicate, it is actually pretty simple. It's not too different from the Go method, except that I think Go you can copy receivers without any issues. But I mean, that's I guess the garbage collector kicking in for you. Right, I suspect this is the end of Advent of Code 2019 until I finish 2025. So I'll see you on the other side.